Hello everyone. So today we have some tasks and code correction based on the programming principles Dry, Keys, Yarny and Solid. So I took this code and pasted here, so now we can solve the problem. So in this case, this piece of code, it violates the principle dry, which stands for don't repeat yourself. So we have three methods which are identical. They return the sum of numbers. So this returns sum of two numbers, 3, 4, etc. So what I would do is I would get rid of this. I would get rid of this, and instead of having two inputs, I would probably give a list of numbers. So let's declare a private list, let's say double. Alright, so let's call it number list. Alright. Number list. And here we want to have a list of double. Let's call it number list. Of course, we need to import the library. Right? We need to import the library. So right, so this is an empty list. We want to pass the list from the main method. So let's say we have a list of double. Let's call it list, and I will declare an array of numbers. So let's say 1, 2, 3, 4, 5. Right, again, yes, this is a double list, so we have to pass in the double values. Alright, so we have our double values. Now we need to create an instance of class math operations. Let's say math, new math operations. Alright, and here actually we don't even need this private list. Let's keep it simple. Okay, so we have our list, and we can either use the iterator. So yeah, let's use the iterator of type double, and we need to import this. Let's call it iterator number list dot iterator. Right, so while iterator has next, so it's not empty. What we're gonna do, we want to have a global variable. Let's say double sum. Let's use the wrapper class since we're using the wrapper here. So sum initially 0, do, we're gonna say sum plus or equal to iterator next. Alright. And in the end, we'll return the sum. Alright. Let's try to call our method. So math dot add up all the numbers in our list, and then we want to return and to print out this. So let's run this. Take some time. So we have incompatible types. We were passing double. Iterator was double. Okay, let me use a for loop instead of iterator. So I'm gonna use for double for each number in our number list. I should have left the sum 0. Alright, so we're gonna do sum plus or equal to the number. Alright, and we're gonna return sum. Okay. I see. The return type should be double. That's the problem. Okay, so actually it works. 15. 1, 2, 3, 1, 2, 3, 6, 10, 15, yes. Again, let me use my previous solution with the iterator. So I forgot about the integer. So double. Okay, this should work as well. So this is the second solution. Okay, let me keep this one. But actually the one with the for loop was simpler, I guess. Okay, never mind. Let's move to the next task, which is discount calculator. So we have this piece of code, and we're asked to use. We need to simplify the code. So I need to simplify the code, and it violates the keys programming principle. So keys stands for keep it simple, stupid, and this code is overcomplicated, as you can see. So now we need to simplify this code. How can we do this? Well, let's define another variable. Let's call it rate. So in the end, we will return price times 1 minus rate. So this rate. Now let's define the rate. So what is rate? So we have is loyal customer. So is loyal customer, right? And then we have a condition here. So if it's a loyal customer, and if if is first purchase, so if first purchase, right, then we're gonna make 10% discount. So if it's a first purchase and it's a loyal customer at the same time, then we're gonna make 10% discount. So price not the price, but 0.1, 0.10, right? So if it's a loyal customer, and if it's a first purchase, then 10%, else 5%, right? And else if the customer has coupon, then 7% discount, else 2% discount, right? So this is our rate. And we can get rid of this one, and we don't need this discount. Alright, now this should work fine. Let's test this one. So let's create discount strategy, new discount strategy. Actually, it's a discount calculator. New discount calculator. Right, so now let's call the method calculate discount. So calculate discount, we need to pass the price. Let's say 100. Okay, so the price will be 100. Is it a loyal customer? Okay, let it be a loyal customer. Is it the first purchase? Let's say not the first purchase. And let's say the customer has coupon. So the result should be, so loyal customer. Okay, loyal customer, first purchase. 0.5, but it has coupon, so should be 7%. So we should have 93. The result should be 93. So let's print this out. I'll run this. 95. Interesting. So the discount was 5%, not 7. Actually, this is the correct version because, as you can see in the code, I will take this code again. I'll paste it here. So as you can see here, we have loyal customer, and then within the loyal customer we have the first purchase and else statement, right? Then we have else. So this is not for loyal customer, So we have the has coupon and else discount. So yeah, if we put the loyal customer false, then it will automatically go to this side. The discount will be 7% in this case. What if we say that this is not the first purchase? Will it change? It didn't change. So even though it is its first purchase, but it's not a loyal customer, it didn't go inside this stage, so it switched to the else if statement. Alright, let's move to the next one. This is Yanni. So Yanni is a programming principle that stands for you ain't gonna need it. So in this case we have a user with a name, email, phone number and etc. And we only use name, email and phone number. So the rest, we don't need that, we can remove that. Alright, so now this is a cleaner version. We only have the fields that we use that we need. Alright, next one, single responsibility principle. So order. We have class order, which has process order, send email, generate invoice, so many tasks, so many responsibilities. So this code violates the single responsibility principle, the first letter of the solid. So according to the single responsibility principle, each class or interface must have a single responsibility. So how can we solve this problem? Well, we can create, we'll keep the process order and we'll create an interface, email sender, invoice generator. Let's create an interface. So interface, let's say email service and invoice service. Right, so we have the email service. What is it gonna do? It's gonna send an email. So I will take this part. We'll have void let's say send. Alright. And for the invoice, generate invoice. So I'll say void generate. Okay, so now what we can do is we can implement the email service and invoice service. So this is for send, this is for generate. Okay, and I'm gonna put the overwrite annotations here. Right. Now it satisfies the single responsibility principle, where each method, each interface has its own responsibility. So yes, let's move to the next one, payment service. Payment service. So this principle, it violates the open-close principle, which means that open-close principle, it stands for, OCP. It means that the code should be open for extension and closed for modification. Alright. So how can we do that? Let's create a new interface, which we'll call payable. Okay, and it will have a method pay. Alright, so then we can have credit card, PayPal, and Bitcoin. So let's create classes. Credit card, payment. Let me create a new package here. This package for open close principle, so this is OCP. Credit card, payable, payment process. Yes, I'll take these and put inside. Okay. And then we'll have another class, PayPal. PayPal payment. Right, and Bitcoin. Bitcoin payment. Okay. So each of these classes will implement the interface payable. Okay. Payable. Then we'll override the method pay. So this is a credit card. We'll take this one, copy it and paste here. And let's specify here pay some amount, double amount. This one, this is for PayPal. PayPal implements payable. It will override the method pay and print out this message. PayPal payment. Okay. The same for Bitcoin. Bitcoin payment. Now we can get rid of this if else, a bunch of if else statements. instead of payment type, we'll have the payable interface, payable. Okay, and we'll call payable.pay the amount. So this is our main class. Now if we want to test this one, we can create a main method. We can create payment processor. Let's say processor, new payment processor. Let's create payable, let's say credit card. This will be credit card payment, and then we call processor, process payment, credit card, and let's say 1,000. Right, and if we run this one, we can get credit card payment. If we say Bitcoin, we just need to change this to Bitcoin payment. Now we're good. We can pay with Bitcoin. Like this. Alright, now we can move to the next task. So we have a bird, alright, so class bird that has method fly, and it prints out the message bird flies. And then we have class penguin, which extends the bird. So this violates the list of substitution principle, which stands for it means that a subclass must behave like a base class. So if we put a subclass into if we use a subclass instead of the base class, it should not violate the method. The program should not crash. But in this case, if you try to call the method fly from the penguin, it will throw an exception which is already a violation of the list of substitution principle. So what we can do in this case is we can create, let's create a new package. It's a list of substitution principle. I'll put here the bird. Here's the bird here. I'll take this bird and put it inside. Okay, and I will create a new interface, flyable, and it will have the method fly. Okay, and here in the bird class, actually bird should not fly, but we can create another class. So let's create another class. Let's say class sparrow, and let's say it implements the method. Actually, it extends the bird first of all, and implements flyable. Alright. So now it should override the method fly. So we'll put override public void fly, and it will print out a message sparrow flies, like this. And I will remove this one. So bird let's say bird can make sound. So bird makes sounds. It says I'm a bird. I am a bird. I'm a bird. Okay. I will take this one. And here this will be I'm a sparrow. Overwrite. Copy this one. Now Penguin does not need to implement, it does not need to throw an exception to the method fly, which we used to do before. In this case, bird does not have the method fly. It became a more general class, and so we can put the make sound method and a penguin. Yes. So with this interface flyable, now this satisfies the least code substitution principle, and the subclass penguin behaves like a base class bird, so it does not have the method fly, right? Let's move to the next one, worker. So we have an interface worker which has two methods, work and eat, and we have a class programmer that implements worker, and we overwrite the method work and eat. Here it throws an exception, programmer does not eat at work. So this violates the interface segregation principle, which means that an interface cannot have it should not have multiple methods, and the classes should not give an implementation to the methods that it does not need. So we must not force the classes like this to implement the methods that they don't need. So what we can do instead is let me first of all create a new package here. So package for interface segregation principle, ISP, and we have this programmer. Put it in ISP. Here we go. So I will create a new interface. Let's say workable and eatable. So we will separate these methods. Eatable, yes. And I'll take this eat and put it here. Eat and work. I'll put it here. Right, now we don't need this one. Programmer implements the workable. Now we can remove this one. So this is how we fix it. Now it satisfies the interface segregation principle, the interface segregation programming principle. Alright, and the last but not least, we have notification service. So we have a class notification service, we have private email sender, and this class I suppose, and we have a method send notification, email sender, message, yes. So this class has a method send email, takes a message and prints out that message. So this piece of code, this class it actually violates the dependency inversion principle, which means that a high-level implementation should not depend on low-level implementation. Instead, they both must depend on abstractions. So how can we fix this? So now notification service depends on the email sender, so it creates an instance of a class email sender inside itself. So to fix this, you can create an interface. Let's call it notifier, and it will have a method send some message. Okay, and email sender, it will implement this message, this notifier, and we have an override here. Okay, so now we don't depend on the low-level implementation, i.e. email sender, but on the other hand, instead we depend on a high-level implementation notifier, and let's generate a constructor. Right, so we depend on the notifier, and instead of email sender, we say notifier send message. Now if we want to add some extra functionality, we can just add another interface, maybe SMS sender or something, etc. So we can implement new behavior without changing the internal code of the notification service. So instead of creating an instance of class email sender inside the notification service, we injected it from the outside using the interface notifier, and now it satisfies the dependency inversion principle. So thank you for watching, and I'll see you in the next video.